Hi, I'm audible. Please, anyone. Hi, good evening, everyone. If I'm audible, please say yes. Okay. So we'll wait for 2-3 minutes and then we'll start. Good evening. Hi, good evening. Yeah. Okay. So Jai Hind, everyone, and good evening. Myself Vaibhav, and I am your instructor and mentor. Not for today class because I am dealing with the digital part and FPGA part. So today I am here for a 5 minutes, and I want to convey my message. Ki why we have taken this initiative and what is the purpose, what is the aim, and what is the objective of this session. Okay, so myself again, I am Vaibhav and having a 21 years of experience, and from last 11 years, I am running this academy with a passion to help my juniors to make a career in a VLSI and embedded system. Okay, so again, in last 11 years, we are totally focusing on offline, and we have many students who are not local to this place, but they are from south, east, and west. So many of them requested, "Ki sir, why not you can start your learning online?" Okay, because we can't come there. Okay, and we want to see what exactly you are sharing. So this is the feedback we got from last few months, and so we have decided to start the session freely, no cost, no registration, to my juniors from all over India. Okay, so but again, the question is why I have chosen a different domain. Why not one domain? As per my experience, why you guys have to come in this domain, either in VLSI or embedded. This is very important. Okay, we don't have to follow the blindly. This is very important. If we start following the blindly anything, we are not going to survive in this domain. Okay, so what is my uh, guru month to everyone? Okay, in VLSI or in embedded, you have to decide any one thing out of three or four domain. First, first analog, second programming, third digital, and fourth is hardware. Okay, a person who is working in this domain, either in analog or I can say either in VLSI or in embedded or I say hardware, he is not working in all the domain. He is working in any one domain. Okay, so why I am asking you to choose any one domain? Because if I don't know where I am having my interest or what is comfortable to me or where I can prove myself confidently. For example, people are saying programming is very good, design and verification is very good, etc. etc. If I am not comfortable in writing the program, if I am not able to make a logic, then do you really think that I can perform in design and verification? No. I can take a job, but I will not survive. Similarly, if someone is saying analog is awesome, if you start your career in analog, no one can follow in terms of money. Yes, again, very true. But do you really think analog? Do you really understand analog? No. Okay, again, you will be in trouble if you don't understand the analog. Similarly, yeah, hardware is very good, embedded in every colleges, in every semester, people are working on robotics, people are working on AI, ML, etc. etc. But if I don't understand the hardware, do I perform in hardware? No. So what we have to do? Either I'm a fresher, either I'm a pass out, or either I'm a pursuing second year, third year, fourth year. We have to first identify our interest. If I am good in analog, I understand the KCL, KVL, RC, MOSFET, op amp, amplifier, I should start thinking of analog domain. But yes, you have to compare with two things. One is programming, one is digital, one is hardware. Okay, so everyone cannot take the input of all the domain. So that is the reason I have taken the initiative to give you the free session on every domain, at least 10 to 15 or 20 classes in every domain, so that the current generation aspirants from from our engineering background, electrical electronics, they should start thinking of making the career. Again, in 1 minute, if you are in second year or if you are in third year, this is the right time to think about which domain is the best for you. Okay, if you are in fourth year, you already have lost the time, but you don't have to worry. Again, don't be uh, don't run. Okay, take some time, think for analog, think for digital, think for programming, think for hardware, and then choose any one. If you are fresher or if you are passed out, and or if you have a gap, again invest 3 months in understanding all these domain, and then go for the full-fledged learning for complete 6 month or 9 month, and then go for the any placement. So this is the Guru month, which basically I am doing here from last 11 years, and out of 1,000 students, I have developed this knowledge, like analog, digital, programming, and then in fourth year they choose their domain. Sir, I love analog. I want to go in analog and layout. Sir, I love programming. I want to make my career in design and verification. Okay, so this is what I want to express you here. So from now, my colleague Devansh will come here and he will start the session in C for next 10 days or 12 days. Okay, again, objective is not a theory, practical, pure practical exposure we are going to give you, pure practical exposure, so that with the help of C, you can start thinking about FPGA, you can control FPGA, okay, with the help of SoC. There is a ARM processor inside the FPGA. You can control those ARM processor with help of C. So C is required. Second, system C. Okay, system C is a modeling, virtual prototyping domain in design and verification. If you know the C, you can start thinking of C++, and then you can start thinking of system C. Third, embedded. Why embedded? Because you have to control the many interfaces starting with LED, LCD, LED, SSD, keypad, UART, I2C, SPI. If you don't know the C, you can't understand embedded C. So with help of C, you can do a lot of things. And last, if you're part of design and verification, if you know the design and verification, without C, you can't go for system Verilog and UVM, because interviewer can ask anything on C or C++. Okay. And last, in your college placement, if you're good in C and C++, you can compete with our brothers in CS and other domain. You can be a good part of these IT companies with the help of C and C++. Okay, so that is why I request everyone, please be focused, ask the questions after the completing of the meeting. My colleague will reply, and if you are in part of WhatsApp group, please come and discuss your queries. Okay, all the best. Thank you. Bye bye. Jai Hind.
Okay, so Vaibhav sir has already told you about the importance of C language, and today I will be your instructor for C programming. My name is Devansh, and I have over 4 years of experience as a software engineer, and I have worked on languages like Java, Python, and C++. And currently, I am a C and C++ instructor here at Pine. So, since this is a 1 hour session, let's directly jump into the topic. So, what we will discuss today is, since we have to start with very basic topics, because I'm assuming that you don't have any prior knowledge, and even if you do, you can stay and you might learn something new. So, let's start with very basic topic. number systems. Okay, so what will we study in number systems? I'm not going to teach you very theoretical about number systems, just the stuff which is required to do the programming and solve programming questions. In number systems, we need to study how to convert a number in other number systems. For example, converting decimal to binary, binary to octal, hexadecimal to binary, and these type of things. So let's start with a basic example. So suppose I have a number 78 and I need to convert it into binary form. What I will do, I will start dividing it by 2. So binary number has base 2 because it contains only two numbers, 0 and 1. A decimal number has a base of 10 because it contains number 0 to 9. Okay, in binary we have 0 to 1 and in decimal we have 0 to 9. In octal the base is 8 and it contains number 0 to 7. And in hexadecimal the base is 16. It contains numbers 0 to 15 in which 0 to 9 are numbers, and from 10 to 15 we have alphabets A to F. Okay, so to represent numbers 10 to 15 we use alphabets. So 10 is represented as A, 11 will be represented as B, and so on. Okay, so this is the basics of all types of numbers: binary, decimal, octal, and hexadecimal. Now here I have taken a decimal number and I want to convert it into binary. Okay, so what I will do is I will divide this number by 2. If I divide this number by 2, I get 39 and the remainder will be 1. Okay, 78 divided by 2, I get answer as 39 and the remainder will be 1. I will again divide this number with 2. So I will get answer as 19 and remainder will be 1 again. Again I will divide this number by 2 and I will get, okay, sorry, I will get here 9. 2 nines are 18. And again I will get 1 as in remainder. Dividing 9 by 2, I will get 4, 1 as a remainder. Dividing 4 by 2, I will get 0. Dividing 2 by 2, I will get 0. And at last, we have 1. Since 1 is smaller than 2, we can only multiply 2 with 0 and this is how we will get 1. Okay, so if you didn't understand this part, just let me show you. I can't do 2 ones are 2, right? Because 2 is greater than 1. So I can write this. So we get remainder as 1. Now we have noted down all the remainders. What we will do, we will write them from bottom to top. So 1, 0, 0, 1, 1, 1, 1. So this is the binary conversion of 78. Okay, this is the binary conversion of 78. Now, if I want to convert this number back to decimal, how do I do that? I can simply multiply each of them with the increasing power of 2. So 1 will be multiplied by 2 to the power 0. This one will be multiplied by 2 to the power 1. This one will be multiplied by 2 to the power 2. This will be multiplied by 2 to the power 3, 2 to the power 4, 2 to the power 5, and 2 to the power 6. We will calculate these and we will add all of them. So 2 to the power 0 is 1, 2 to the power 1 will be 2, multiplied by 1 will be 2. So let me write it down below so that we have enough space. So 2 to the power 2 to the power 0 multiplied by 1 will be 1. 2 to the power 1 multiplied by 1 will be 2. 2 to the power 2 multiplied by 1, 4. 2 to the power 3 multiplied by 1 will be 8. 2 to the power 4 multiplied by 0 will be 0. 2 to the power 5 multiplied by 0, 0. 2 to the power 6 multiplied by 1. So we have here 64. So if we add all of them, we will get 78 as the answer. So this is the conversion of decimal to binary, and this is the conversion from binary to decimal. So this is a very simple example and it is a very simple process. Uh, we can do a very small example again. Okay. Now let's suppose I need to convert decimal to hexadecimal. Okay, I need to convert decimal to hexadecimal. So what I can do is I can take another number, suppose 104. Okay, now I'm converting decimal to hexadecimal. In this case, I will divide the number by 16. Earlier we were dividing the number by 2, now we are dividing the number by 16. So we will use 16, 6, the 96, okay, and the remainder we get is 8. 16, since 16 is smaller than 6, we can only write 0 here and we will get the remainder as 6. So 68 is the hexadecimal conversion of 104. Okay, so 68 is the hexadecimal of 104. Now you might be confused that 68 seems like a decimal number because in decimal we have 0 to 9 and this number contains 6 and 8. So it can be a decimal number and you are right to think, but to avoid the confusion, whenever we write any number in case of programming, we write the base of that number along with it. If I write 16, this like this, it will be understood that this is a hexadecimal number and it is not a decimal number. So this is the conversion of decimal to hexadecimal. Now you might have got the idea, if I want to convert decimal to binary, decimal to octal, decimal to hexadecimal, to I just need to divide the decimal number by the base of that number. So if I was converting decimal to binary, I was dividing the number by 2. If I was converting decimal to octal, I was dividing the number by 8. If I was converting decimal to hexadecimal, I was dividing the number by 16. Okay, so it is very simple because the process is same, it's just the base is getting changed. So what will happen if I want to convert hexadecimal to binary directly? Okay, what will happen if I want to convert hexadecimal to binary directly? Now, many students go with the traditional approach. What they do is they convert hexadecimal to decimal first, and then they convert decimal to binary. Okay, so suppose I have a number, binary number like this, and I want to convert uh, this. So let me take this another example. 1101. Let's take this example. Okay, suppose I want to convert this number to hexadecimal. It is very simple. What I can do is I can first convert it to decimal, and then I can convert it to hexadecimal. It is very simple. So to convert it into decimal, I will multiply with this number by 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3, and adding them all like we did previously. This will be converted to decimal, and then from decimal I can easily convert it to hexadecimal by dividing the number by 16 and noting down the remainders. But there is an easier way. Suppose I have a binary number like this, and I need to convert it into hexadecimal. Now, if I convert it into decimal first and then hexadecimal, it will work. It will give the correct answer. But it is a little bit lengthy because we are calculating multiple times. Instead of that, what we can do is I can make pair of 4 from right side, always from the right side. I will start making the pair of 4 like this. And if you notice, we have only 3 digits, so I can append a 0 on the left side, and this is how I can again create a pair of 4. So I have 0, 0, 0, 1, 1, 0, 1, 1, and 0, 1, 0, 1. I have 3 pair. What I can do right now is I can simply convert them according to standard conversion. So this is the binary of 1. Okay, this is the binary of 1. This number is the binary of 11. 1011 is the binary of 11. Now, how do I know that? I have remembered the binary conversion till like 15 or 16. I know the binary conversion till 15 or 16. So I know that this is a binary conversion of 11. But you can always calculate it again using the same technique by multiplying this one with 2 to the power 0, this one with 2 to the power 1, and so on. So this is 11. And like I said, in case of hexadecimal, the numbers from 0, so this will be 0 to 15. The numbers from 10 to 15 are represented by letters. So A is 10 and B was 11. So this is B. And this is the binary of 5. So if you remember the binary of some numbers, this process is direct. You can just directly convert this number to this. So this is 1, this is 11, and 11 in hexadecimal is represented as B, and this is 5. So 5B1 is the conversion. This is in hexadecimal. So what I'll do is now, I will I will write a general rule for conversions. You can note it down. It will be helpful for you. You don't need to remember like when do I need to divide, when do I need to multiply. It is confusing in the beginning when you have not practiced these things initially. But what I'm going to do now is I will write the general rule, and with the help of that, you can always practice and you will be able to remember it easily. So whenever we want to convert, so whenever you want to convert decimal to binary, decimal to octal, or decimal to hexadecimal, you need to divide 2, divide by 2 in this case. You need to divide by 8 in this case, and you need to divide by 16 in this case. Okay. Every process is same. You just note down the remainders, and at the end you note it down from bottom to top. Okay, from bottom to top. So to convert decimal to binary, you use divide by 2. To convert decimal to octal, you use divide by 8. And to convert decimal to hexadecimal, you use divide by 16. Okay. Now to convert binary to decimal, you simply do to convert binary to decimal, you simply multiply by 2 to the power x. X will increase from right to left. So first number from right will be multiplied by 2 to the power 0. Then the next number will be multiplied by 2 to the power 1. Then the next number will be multiplied by 2 to the power 2, and so on. Okay. So this is the basic conversion which you can remember. Right. Again, if you want to convert octal to decimal, you will multiply by 8 to the power x. Again, x will increase from 0 to ahead. In case of hexadecimal to decimal, you will multiply by 16 to the power x. Okay. 2 to the power x, 8 to the power x, 16 to the power x. X will increase from right to left. So this is what you can note down. It will be helpful for you. So this sums up almost everything. And I've shown you, like, if you want to directly convert binary to hexadecimal, you can make pairs of 4, and then you need to remember those binary equivalent of decimal, and then you can write it like I shown you in the previous example. So this is all about number system, because this is sufficient for what we are going to study and what is required in programming. This is not something which is asked directly in the interview, but there are several questions where you might need the information from here. So this information is not directly important for the interview, but it is helpful in solving certain types of problems. And specifically, if I say bit manipulation, you can solve a lot of problems with this information. So this was all about number systems. Let's move ahead to the next topic. Okay. So let me check if you have any doubts or not? Okay, so let's start with the main stuff, which is operators in programming language. In programming, we have multiple types of operators. Okay, so we have different types of operators. Let's start with this arithmetic operators. Arithmetic operators are the operators which we are already using in our programming language since very long. So this contains plus, minus, multiply, divide, and modulus. Okay, now I'm again saying that these topics might be very basic for you, but as we stated that we will be starting from ground up, we are assuming that you have no programming language, although many of you might have the knowledge, but still we are going from the basics. So plus is used to add, subtract, multiply, divide, and this is the modulus operator. Okay, so in case of modulus operator, if I use modulus operator between two numbers, it returns the remainder. So 5 divided by 2, the remainder will be 1. So this will give me 1. Okay, so 5 divided by 2 will be 1. So remember that this returns remainder. Okay, this operator might seem very simple now, but it is very helpful. It is very helpful. Let me give you an example. Suppose I have this number 568392. I have a large number 568392. What I need to do is I need to extract this last digit. If I do modulus by 10, modulus by 10, it will always give me the last digit of that number. If I do modulus 10 of any number, it will give me the last digit of the number. Okay, so it can be any number. 486 modulus 10, it will be 6. You can try 486 divided by 10 and the remainder will be 6. So just remember that whenever you mod 10 by any number, okay, you can do mod 10 of any number, it will always give you the last digit. And if you do divide by 10 of any number, okay, if you do divide by 10 of any number, it will give you all the digits except for the last one. So this will give 48. Okay, if you divide a number by 10, it will give you all the digits except for the last one. But if you do mod by 10, it will give you the last digit. This is very helpful when you are solving a problem like reverse the digits of a number. Okay, so you have a number. Let me erase this first. So suppose you have a number and you want to reverse it like 5213. So mod and divide operator are very helpful in this kind of question. You can simply separate 5 with mod 10. You can separate rest of the number by dividing by 10. We will solve this question when we will cover loops. But for now, just remember that whenever we do mod 10, we always get the last digit of a number. When we do divide by 10, we get everything except for the last digit. Okay, so this is arithmetic operators. Next, we have unary operators. So unary operators are all those operators which have only one operand. In case of arithmetic operators, we were doing 5 plus 2. So this operator has two operands, 5 and 2. But in case of unary operators, we have only one operand. So they operate on one operand only. So let me give you an example. So we have plus plus and minus minus mainly. So these are not the only unary operators. We have other unary operators as well, but we will categorize them into different other categories. For now, we will study just plus plus and minus minus. Okay. So we have other unary operators as well, but they can be part of other category. So plus plus is the increment and minus minus is the decrement. Okay, now increment can be post and pre. Similarly, decrement can be post and pre. Okay, so post increment, pre increment, post decrement and pre decrement. So let's suppose I have a number x equals to 5, and if I do x plus plus, what it will do, it will make the value of x as 6. So it will become 6, right? And if I do x minus minus instead of x plus plus, so this will become 4. So plus plus increments a number by 1 and minus minus decrements a number by 1. Okay. Now, when I wrote this post and pre, what did I mean? So So post means use first, change later, and pre means change first, use later. So I'm going to write an example, and then you will be able to understand what I am saying. So what I've done is I've taken a variable x which has value 6, y which has value 8. Here z is equals to x plus 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 y. So if you see that I have used this plus plus operator everywhere, and now we will be able to understand what do we mean by post and pre. So when I write plus plus after an operand, if I write x plus plus, so plus plus is coming after the operand, it is post. And if I write plus plus y, then this comes before the operand and it is pre, right? So x plus 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 y, we will solve this with the help of memory thing. Okay, so currently x has 6 and y has 8. I'm doing x plus plus. X plus plus means post. Post means use first, change later. So what I will do is I will use the current value and then I will change it to 7. Okay, so first I have used the value and then I'm changing it to 7. Okay, now plus plus y. In case of plus plus y, this is coming before the operand which is pre. So change first, use later. So what I'll do is I'll change it to 9 and then I will use it here. Next, again I have x plus plus, which means use first, change later. So current value of x is 7 and then I'm going to change it to 8. Then I have y plus plus, which means use first, change later. So I will use the current value 9 and I will change here 10. So the final value in x will be 8 and in y will be 10, and in z we can calculate it. It is 15, 7, 22, 22 and 9. It will be 9, 6, 15, 15, 7, 22. It will be 31. So z will be 31. So this is what post increment, post decrement, or pre increment or pre decrement means. So if it is a post increment, which is like this, you use the value first and then change later. And if it is a pre increment, you change the value first and then you use later. Okay, so this was all about unary operators. There are other unary operators as well, as I said, but we will cover them in the different category. Okay, let's understand bitwise operators. In bitwise operators, we have bitwise and, bitwise or, bitwise not, XOR, left shift and right shift. So these are the different types of bitwise operators. So first let's understand what are bitwise operators. So bitwise operators are those operators which act directly on the bit of a number. We know that every number in the computer is stored in the form of binary, but whenever we do calculations with other operators, we do them directly. Like whenever we do 5 plus 2, we don't think in terms of binary numbers, right? So they directly do 5 plus 2, which is 7. But in case of bitwise operators, we do action on their bit. Now this is and, this is or, this is not, this is XOR, left shift and right shift. I am assuming that you are familiar with basic gate tables like AND gate, OR gate, NOT gate, but still for your reference, I will repeat that topic again. So in case of AND, the two inputs, if they are 0, 0, we get 0. If they are 0, 1, we get 0. If they are 1, 0, we get 0. And they are 1, 1, we get 1. So this is the table for AND, right? In case of OR, if they are 0, 0, we get 0. If they are 0, 1, we get 1. If they are 1, 0, we get 1. In case of 1, 1, we get 1. So this is the table for OR. Okay. In case of XOR, if they are 0, 0, we get 0. If they are 0, 1, we get 1. If they are 1, 0, we get 1. And if they are 1, 1, we get 0. So if the inputs are different, we get 1. Otherwise, we get 0. So this is the table for AND. This will be the table for OR. And this will be the table for XOR. Okay. So based on this, let's understand how they are used in programming and what happens behind the scene. Right. So suppose I write 5 and 4. Okay. So 5 and 4. Since it is a bitwise operator, it will act on the bit level. So converting 5 to binary, it is 0, 1, 0, 1. Converting 4 to binary, it is 0, 1, 0, 0. Okay. So 5 has binary 0, 1, 0, 1. 4 has binary 0, 1, 0, 0. If I do bit by bit and, let's see, and of 1 and 0, and of 1 and 0, it will be 0, and of 0 and 0, it will be 0, and of 1 and 1, it will be 1, and of 0 and 0, it will be 0. So this is the binary of 4, so it will result into 4. Okay, so whenever we use bitwise operator, it acts bit by bit of both the numbers. If I use XOR, suppose if I use 6 XOR 8, it will be 6 will be 0, 1, 1, 0, and 8 will be 1, 0, 0, 0. Now, in case of XOR, if 0 and 0, we get 0 and 0, so it will be 0. 1 and 0 will be 1, 1 and 0 will be 1, and 0 and 1 will be 1. So this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 4 plus 2, 6, 6 and 8, 14. So this is 14. So this will result into 14. So that is how these operators work, and, or, not, and XOR. Let me explain the not operator as well. We know that not gate just inverts the input. If we get 0, it converts it into 1. If we have 1, it converts it into 0. So if I write not of 5, right, and considering that we have only 4-bit system, the binary of 5 is 0, 1, 0, 1, right? Binary of 5 is 0, 1, 0, 1. If I reverse this, I get 1 because it was 0. So it will be inverted to 1, it will be inverted to 0, it will be inverted to 1, and it will be inverted to 0. So whatever was 1, it became 0, and whatever was 0, it became 1. So this is the XOR operator. Sorry, this was the NOT operator. Okay. Now let's understand what are these operators, left shift and right shift, because they don't directly belong to the gates table. So suppose I am doing 5 right shift by 1. I'm writing like this. So this is 5 right shift by 1. And since it is a bitwise operator, it will act on the bits of 5. And considering that 5 is stored as 0, 1, 0, 1, what it will do, it will shift all the bits of 5 by 1 position, because here I have written 1. So 5 right shift by 1, that means all the bits of 5 will be right shifted by 1. Since this bit is already on the rightmost side, it will get dropped. Okay, it will get dropped. This 0 will come here, this 1 will come here, and this 0 will come here, and an additional 0 will be added towards left. So on right shifting, this one was dropped, this 0 will come here, this one will come here, this 0 will come here, and an additional 1 will be here. Okay, sorry, I guess I took another. This one will be dropped, this 0 will be here, this one will be here, this 0 will be here, and this 0. So this is equivalent to 2. Okay, so this is equivalent to 2. Similarly, if you do left shift, all the bits will be shifted one position towards left, and an additional 0 will be added from right. So let's take this similar example and I'll do left shift. So if I do 5 left shift by 1. Okay, so this bit is already on the leftmost side, it will get dropped. This one will come at this position. This 0 will come at this position. This one will come at this position. And at the end, another 0 will be added from right. So this is equivalent to 10. So that is how left shift and right shift operator work. Okay. Now, an interesting fact, it was asked in one of the interviews that you have to divide a number. Okay, you have to divide a number by 2 without using arithmetic operators. Okay, you have to divide a number by 2 without using arithmetic operators. So the question was based on bitwise operators only, because whenever you do right shift a number by 1, any number it can be, if you do a right shift any number by 1, it will become twice. Okay, it will become twice. Sorry. Sorry. If you do a left shift, I'm sorry, I was not paying attention here. If you do a left shift a number by 10, number by 1, the number becomes twice. And if you do a right shift of number by 1, and it will become x by 2. Okay. So this you can remember, that if you do a left shift a number by 1, it becomes 2x. If you do a right shift a number by 1, it becomes x by 2. Okay, and here we have seen the example. I'm doing right shift 5 by 1. What did I get? 2. Since it's programming and both the numbers are integer, we can't get 2.5. We got 2. And when I did left shift of that number by 1, the number got doubled. So from 5, I got 10. Okay, so just remember, left shifting a number by 1, we get 2x. Right shifting a number by 1, we get x by 2, which means the number gets half. So this was all about bitwise operators. Okay. Next, we have relational operators. Okay. Relational operators are used to check conditions. So it includes less than, greater than, less than, equal to, greater than, equal to, and double equal to. Okay, so these are relational operators. So if I write 5 less than 2, 5 less than 2 is not true, because 5 is greater than true. Okay, 5 is greater than 2. So this will return false, or we can say 0. In case of programming, 0 is considered as false, especially in C and C++. 0 is considered as false, and any non-zero number is considered as true. Okay, so this will be false. So these kind of conditions are used in case of loops, in case of if else. So all these things are used in loops and if else heavily. So less than, greater than, less than, equal to, greater than, equal to, less than, equal to, that means if I write this 10 less than equals to 15, it means that 10 should be either less than 15 or it should be equal to 15. If any one of them is true, it will be considered as true. So this will be true because 10 is less than 15, right? This is used to check the equality. If I write 3 equals to 3, that means both the numbers are equal and it will be true. If I write 4 equals to 3, both the numbers are not equal and hence they are this false. It is false. Okay. One more operator we have here, which is not equals to. Okay, so now if I write 4 not equals to 3, this is true because the operator says not equal. So since 4 is not equals to 3, it is true. Okay. Next, we have logical operators. Logical operators have logical and operator, logical or operator, and not operator. Logical and, logical or, and not operator. So let me get rid of this first. Now, logical operators are used to combine multiple conditions. Okay, logical operators are used to combine multiple conditions. So suppose I write something like this. Okay, 5 greater than 2 and 3 less than 1. Now note that this logical AND operator will work exactly like the AND table which we have studied in electronics. So this 5 greater than 2, 5 is greater than 2, which is true, since so we can write here 1. As I said, in case of programming, non-zero number is represented as true. So since this condition 5 greater than 2 is true, I can write 1 here, which is true. And 3 less than 1, 3 less than 1, this is false. So I can write here 0. Now what is the AND of 1 and 0? It is 0, which means this overall condition is false. Okay, this overall condition is false. Let's take another example. Okay, 10 is less than or equal to 9. I have used OR operator, and 5 greater than 2. So 10 is less than or equal to 9, which means this is false. 10 is neither less than 9 or nor it is equal to 9. So this is false, which means I can write 0. OR operator, 5 is greater than 2. So 5 is greater than 2. This will be true. So the OR of 0 and 1 is 1. Okay, but before 1 I have used the logical NOT operator, which means it will revert the input. So if it was 1, it will become 0. So this overall condition will become false. Okay, so I'm telling you again, this 10 less than equal to 9 was false, so it became 0. 5 greater than 2 was true, it became 1. The OR between 0 and 1 is 1, and the NOT of 1 is 0, which means the overall condition is false. So this is how logical operators work. Okay, this is very helpful when you want to combine multiple conditions and execute something based on that. Okay, next we have conditional operators. In case of conditional operators, we have if else and we have other ternary operator. Okay, we will look at these topics in next class. Okay, because it will be a little lengthy for now, but we will move on to our next assignment operator. So in next class we will start with if else and ternary operator, and if possible we will look at some of the topics on loops as well. Okay, next is assignment operator. Simply assignment operator is like this, but we have certain variations of assignment operator as well. So if x is equals to 7, so this is the assignment operator. What it does is it assigns the value from right towards left. Simply assigns the value whatever is on the right towards its left. If I write x is equals to x plus 9, okay, so using the variation of assignment operator, I can write the same sentence as x plus equals to 9. So this and this is exactly the same. Okay, same way we have other operators as well. So if I am using x equals to 3 and I write x equals to x multiply by 3, I can rewrite this as x multiply equals to 3. Okay, so this was the assignment operator. I know that many of you might have got bored because these are very basics, but I had to teach them because I was assuming that many of you don't have any programming background, and this is the very basic of the programming. Okay, if you know these stuffs, if it will be very helpful even if you don't practice C in future, you can choose any language, Python, Java. So these operators will be very helpful for you. Okay, so if the basics are strong, you can switch to any programming language quickly, because whenever when you will go into the job, it might happen that you might have to change the language you are working on. It can happen anytime, and if you know the basics, it will take you maximum of 3 to 4 days to get the hang of the new programming language. So this is what I'm trying to achieve here. I'm trying to teach the basics first, these operators first, because when the questions get difficult, these are the operators which are used everywhere, right? One more thing I can tell you with this bitwise and, you can check if a number is odd or even with this operator. Notice that every number which is odd will have a 1 at the rightmost position. So 3 has binary 0, 1, 1. So on the rightmost side, it has a 1. And on every even number, you will find a 0 at the rightmost position. So suppose I'm using 8. 8 has the binary of 1, 0, 0, 0. So rightmost bit is 0. Okay, so this is the difference between the binary of an odd number and an even number. So if you do x and 1, x can be any number, odd or even. If you get 1, the number is odd. If you get 0, the number is even. So this is another way of checking if the number is even or odd. Okay, so someone can ask you that without using the arithmetic operators, figure out if a number is odd or even, right? So the usual method is people use this modulus operator and check if the remainder is 0, the number is even, and if the remainder is not 0, the number is odd. But if you do this, you can still check if the number is odd or even, because if you get 1, you get odd. If you have 0, you get even, because every odd number has 1 on its rightmost position, and every even number had 0 on this rightmost position. So if I do 5 and 1, what happens is 101 and 1 is 0001. So this will be 1 and every other number will be 0. So this becomes 1, right? So this was all about the operators, a very basic topic in programming language, right? In the next session, we will look at if else and loops. Okay, this is how we usually teach in our regular classes as well, because students have studied C programming language mostly in their first semester, in like for 6 months, and this is required to brush up their knowledge so that we can move ahead to the advanced topics. Okay, so this is very important. So that's all for today. Uh, we will meet in the next session, and where we will discuss if, else, and loops, and we will try to solve some of the questions based on loops as well. Okay, thank you.